We're going to be doing synthesis problems starting from benzene using electrophilic aromatic substitution reactions. So let's get started. The first one here, we need to have these, here's an ethyl group and a bromine. So we're going to start from benzene. So first, if you install first, just doing a little bit of, say, analyzing the pathways. Let's do that. So possible pathway. So I'm going to say analysis and see what we need to pick. Let's imagine that in the first place we do benzene, and if we start from benzene and do a bromination, so bromine in iron tribromide, we're going to have bromobenzene. Let's see if starting here it works. So I do bromobenzene. Now bromo is deactivating, ortho pair directing. So can I get that? I'm not going to be able to get that because bromine again deactivating, ortho pair directing. If I choose to do that and do here ethyl chloride, do the Friedel-Crafts, I am going to get substitution either in ortho and para, and that's not the location where I wanted. So that's the para, and I'm gonna get this too. So know what I want. Let's do the ethyl here. All right. So that path will not work. So I'm going to start another way. Let's say that I start, for now, I'm just working on the first problem, right? So let's do that. If I start from, say, benzene, but I do the Friedel-Crafts first, and I do the alkylation, I will encounter the same type of problem because I'm going to install the ethyl group. And again, this is ortho-para directing, activating ortho-para directing. So if I do the bromination from ethyl benzene, I'm still not getting what I need. So what it is, if you see two groups, like here, they are oriented, let's just draw the products first. We see that here in our target, the two groups are oriented meta to each other. So we need to install first a group that directs meta to put the second substituent. And what that is, instead of starting with the alkylation, we're going to do the acylation. So now if instead of doing this, we change this just a little bit and we're doing Friedel-Crafts acylation, and that with aluminum trichloride, this time we're going to get the following. So acetyl chloride and aluminum trichloride and getting that. But now this time, this group is deactivating in directing. So if I do now the bromination, I can get the bromine in the location I want. So I'm going to do bromine, iron tribromide, and I will have this, but not yet what I need, right? But we have a reaction that allows us to convert that group into an ethyl group, and that is the Clemmensen reduction. So we're going to do zinc, mercury, and HCl. So Clemmensen, and that will reduce this to an ethyl group, and I will have a bromine. So again, notice we were analyzing different paths. That's the path that worked, the one in blue. So first we need, since the substituents matter to each other, the first step that we're going to be doing is installing the meta directing substituent. So that is the acylation first, then bromination, and then we're going to be doing the reduction. So that's one. Let's do one more. of the problem. So now let me just summarize what we did for the first. Summarizing what we had at the bottom, the steps are here. First, I'm going to do benzene and the acylation. So we're going to put acetyl chloride, AlCl3. Second, we did a bromination. And third, we did the Clemmensen reduction. The reduction can also be done using, for example, hydrogen in palladium over carbon. That can also work. All right, so that's one. So I'm going to leave the other two for another video.